Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Fadlul Hisham bin Abdul Rahman. Today, we want to discuss about the type of law in fluid mechanics that we choose is hydrostatic pressure. Firstly, as we know, hydrostatic pressure is not dependent on the shape of the vessel concerned but only the height and density of the column of liquid, and as the pressure exerted by a fluid at equilibrium at any point of the due to the force of gravity. Then, hydrostatic pressure is proportional to the depth measured from the surface as the weight of the fluid increases when a downward force is applied. We go to the next section. That is fundamental of principle or law. In hydrostatic pressure, the fluid pressure can be caused by the gravity acceleration of force when in a closed container. Consider a layer of water from the top of the container. There is a pressure exerted by the layer of water acting on the side of the container. As we move down from the top of the container to the bottom, the pressure exerted by the top layer on the bottom adds up. This phenomenon is responsible for more pressure at the bottom of the container. It is because pressure and depth have a directly proportional relationship. When depth increases, the pressure also increases. The formula for pressure is P equal to rho GH. P is the pressure exerted by the liquid in Newton meter square or Pascal. Rho is the density of the liquid in kilogram meter cube, or we call slug feet cube. G is the acceleration due to gravity taken as 9.81 meter second square. H is the height of the fluid column in meter.
This is the village. There were very few residents living in this village. The residents of the village were relying on water pumps for each house to provide them clean water from the river. However, as the resident of the village grows and each house requires a pump of their own to provide water, this increases the cost of living and electricity consumption of the village, which is a bad thing. One day, an engineer decides to move into the village, and to his shock, that each house in the village were using a fairly large water pump. So, the engineer decides to make a change and asks the villagers to help him build a huge water tower tank that stands high above ground level. The engineer explains that the hydrostatic pressure on top of the tower is enough to carry water for each home, only powered by using a single water pump to pump the water from the river into the tower water reservoir. The villagers is so amused with the power of physics in fluid dynamics, so they all decide to learn a few things with the engineer. This is one example of the application of hydrostatic pressure and how it is our daily life routine. This method is currently being used in most civilizations today, not only in civil engineering but also in various other sectors, such as in medical science. Move on to the big question: how the hydrostatic pressure is applied in a water tower. Before we proceed, a basic understanding of hydrostatic pressure is necessary. Here is a cylindrical shape of container containing water. Hydrostatic forces are the resultant force caused by the pressure loading of a liquid acting on submerged surfaces. The principal equation is the differences in pressure equal to density of fluid times gravity acceleration times total height. As for the application in water tower, we can assume that the density is constant as we use water, and the atmosphere is also constant. Thus, by increasing or decreasing the height of the tower and elevation of land, we can alter the amount of force to be produced to deliver the fluid towards surrounding buildings or facilities as needed.
Last but not least, in this section, we'll discuss how the knowledge of hydrostatic pressure can solve the problem arises with the application of water tanks. Using the formula of pressure equals to density times with the gravitational acceleration and the change of height of fluid, the calculated pressure can determine the size and material made to make the water tower. This is a crucial information as a faulty water tank would be a catastrophe to a community. A high amount of pressure in water can cause the tank to leak and also collapse, so it is important to know the hydrostatic pressure of water beforehand in making a water tank. As an example, a plastic water tank can accommodate a low pressure or less volume of water, while steel can hold medium to high pressure of water. And lastly, we have a concrete water tank that can hold a large amount of water that can supply household.